Okay. So also our development lead who cannot be here today is Prashant Bucci, who's doing our programming work and code. And Jeannie Zaleski is the editor-in-chief for physical sciences for all of Pearson Higher Ed. So first I wanted to give you a little bit, since this is a users conference, I want to talk a little bit about our users and the sort of audience that Pearson has for this particular platform. So the platform is known as Mastering. We cover a variety of disciplines for the sciences. This is a higher ed university college platform. It's a tutorial homework system largely. And we started out essentially in mastering physics. This was an innovation that started at MIT known as CyberTutor. So David Pritchard at MIT was a physics professor, and he wanted to design essentially a homework tutorial system that mimicked office hours behavior for students. Understanding that a lot of times students do most of their learning potentially outside of the classroom, and that doing practice on problems over and over again in physics is how students learn to problem solve and to learn the discipline. And yet many students did not do that in class, but would do it at home in the dorms. And so he wanted to design a system that could be taken with the students directly into the dorm, where they would then practice and get some feedback that was like an instructor would give. All right, so the idea of David Pritchard's vision is to bring the instructor into the dorm from the classroom, and potentially he had 300 students. I had 500 when I taught. As an instructor, it's very hard for you to meet the needs of all those students during office hours. Some of them do not come to office hours, and some of them, when they come, you don't have enough time to go through everything that we need. So it started out as Mastering Physics and is now across a variety of disciplines in the sciences and is one of the preeminent platforms for science tutorial systems in the country at the moment. We have, as of this September, 1.7 million registrations for students. Mastering Chemistry is dealing with approximately 400,000 students in Gen Chem and Organic, so first and second year students largely. To give you a little idea about the power of mastering and why it's good, and it's the reason I came to Pearson to work was I was an instructor who believes in the product, so I feel strongly to feel good about it. The idea of mastering is to provide specific wrong answer feedback to push the student in the correct direction. And that these specific feedbacks essentially are written by faculty experts who teach in the classroom, who say basically if a student made this error while I was in the office with them, this is the thing that I would say in order to sort of edge them forward. Not to give them the answer, but in more of a Socratic method to give them some clue and some direction and some feedback on the specific wrong answers. And in organic chemistry, we have a variety of evaluators, and these were written by Bob Grossman at University of Kentucky, who does ACE organic chemistry and has partnered with us for a very long time in developing these evaluators. So we have a large series of evaluators for skeletal drawing and for mechanism reactions for organic chemistry, that essentially the system compares the student's drawing against essentially what the evaluator says should be true, and there are many evaluators that are set for each problem. And mastering is able to say that if the student says that this is the mechanism, then it should produce this outcome. And if it does not, it gives the student specific feedback that says your particular reaction would produce this molecule. That's not what we're trying to produce here. So why do you think this might be? Or sort of give very specific feedback as to why that mechanism is not correct. So we can write very, very specific evaluator responses to students. We can also do some more things that are more general criteria. So if the response has the molecular formula of this, essentially basically give them a more generic response. The structure you've drawn does not have the correct amount of atoms for each element present in alanine. Make sure you draw a structure with the molecular formula and give this to them to give them feedback to think for the next attempt, basically what to do. We also have system-generated feedback for basic drawing issues. Mastering has highlighted one or more atoms in your response that have invalid valence. Right? So basically say this is not right. Like go back and think about that more. You have some options and customizations as well, whether to tell them while they're drawing there's a valence error, like pop up right now while they're drawing it and say, hey, there's a problem, or let them submit it and then give them the response. Like depends on whether are we testing valence or are we testing some more sophisticated mechanism that I'm going to give them a pass on the valence as long as we get to the bigger problem, right? So we can balance that out. We also have a very deep hint structure. So there are hints for every single part, essentially, of an item, and those hints start out trying to take them sort of one step easier. You couldn't get this part, that was too difficult, so let's step down to what's required, which you needed to know, and see if you can do that. And sometimes they're nested many hints deep. If you don't know this in the hint, let's go to another hint below that. Don't get that, let's go down again until you actually catch up with me, and then I'm going to step you forward until we go into the main part. So even before sort of machine learning, adaptive learning became a thing, from the very beginning of mastering was adaptive. This is, if you don't understand, we're going to take you back until we hit a prerequisite, till we fix it, we're going to bring you forward. So we have currently right now Marvin Sketch integrated into mastering for the past 2 years, basically. And we have had some limitations with that, some issues around that. And we want to talk about that and why we're going to MarvinJS as a thing, because it's a major overhaul for us. We're updating our JChem, we're updating our evaluators, we're updating all of our infrastructure, as well as incorporating a brand new tool for front side for students, as well as now also on the back side for our authors. So we essentially have Marvin Sketch on 2 fronts at this point, facing the student and facing the author who's writing the question. The issue with students is they are very chaotic. You think you know exactly how it works and it's all good, and then you put 400,000 students against it and you find all the issues, right, at some level. Students are very chaotic, they have lots of variables, they have a variety of different machines, OSs, things running in the background, they're playing World of Warcraft while trying to do mastering at the same time. And faculty are extremely low tolerance of a problem with the software. It's a very daunting sort of audience. We have a bunch of kids trying to cause chaos with the system, and we have faculty that basically say, this must work perfectly or I'm going to drop you. Okay, so this is our circumstance. Our main issue right now, as one might suppose, is we have a Java problem, right? So Marvin Sketch causes huge amounts of issues with students regarding Java compatibility. That is our main issue. Even apart from usability issues within Marvin Sketch, most of our issues are Java keeps updating, and the student doesn't know how to update it, it doesn't update right, and then they have a problem essentially running the tool. We need to get out of that. We were looking for some faster load times. Students are impatient, faculty are impatient, things need to move faster and be very efficient. I also wanted it to be more user-friendly and less menus, because students have a hard time finding things. I'm not sure where that thing was that I need to do, and I really just want it on the front in toolbars, nice and clean, nice and easy. We also don't need all the functionality that y'all might need, right? Because our students are doing very limited, this is first, second year chemistry, and we don't want to give them too many options, because then they'll use things they don't need, and they'll get it wrong, not because they don't understand the chemistry, but because they don't understand the tool. In organic chemistry, as I remember it, difficult. Right? It's challenging for students, and we want the challenge to be in the actual content, not in the tool. We'd also like to go mobile compatible, at least for iPad, right? So students can start to do things on their iPads. I don't think anyone's going to do this on their phone, but maybe. We don't know at this point. So what we've done basically to work with ChemAxon is to do simplifications. We don't want all of the toolbars on every single item. If this is a 2D skeletal drawing, I only want to give them the tools for 2D skeletal drawing. If it's a 3D skeletal drawing, I only give them the tools for 3D skeletal drawing. If it's a mechanism question, then I'll give them mechanism type things. So things like electron flow arrows and boxes for drawing mechanisms only appear when the question is set by the author as mechanism. The 3D rotations and sort of the focus on up-down bonds and things, those things only occur if this is set as a 3D skeletal. 3D templates only show if it's a 3D skeletal. If it's a 2D, the templates I show are 2D only. So I don't get things that are just wrong because they didn't know what to do. All right? We also want to allow the author lots of control in terms of whether to show lone pairs, whether to tell them that there's a valence error while they're drawing or not. How much carbon or hydrogen, what is the essentially, what does the view look like? How much am I showing hydrogens versus carbons, or am I hiding those things? And also whether or not they can actually calculate RS labels or not. Am I testing RS labels, or am I need it for something else maybe? Maybe I want to help them out. It's a tutorial more than an assessment, right? So I have those options. So we really like the clean design. We like the ability to sort of control and customize the various tools so that they can only do essentially what we want them to do. And we had some usability issues, and this is the electron flow stuff that Effie referred to. Initially, we had some issues that essentially where the electron flow arrow ends up is based on mouse movement. And it's very finicky, right, back and forth. And for a student, it's very difficult for them to tell, am I making a bond here or there? right? And some of them don't know where they should be making the bond, so that's part of an issue. And so what would happen is they would set it up, but it would not be very clear that these two things are different, even with the little blue parentheses, that this is different than this. And particularly the dotted line that indicates the bond that would be created basically goes away once they choose where they want to put it. And so to a student, if you think about it from a student perspective, this and this look very similar, right? And so basically if it's wrong, they don't know why it's wrong. And so that's one of our issues, that it needs to be very visually clear to them what bond they just created, and that needs to maintain so that they know what they did. We also wanted to get away from that sort of moving your mouse back and forth to flick between different bond possible locations, because it's too tentative, right? It's too easy for them to mess that up. And so we also had a faculty saying, it looks like you're drawing them from atoms, not the actual electrons, and you know that as an expert, but students have misconceptions. They don't really understand what they're doing. So you need to make sure that it's clear to them that we're doing electron flow. We're not sort of starting at an atom and going somewhere else, right? So what we've done in the new JS is try to fix the situation by having a very clear arrow that starts up first, where they click where they would like to essentially make that bond, and then they must click to specify which one they mean. So essentially, in this particular case, essentially, do you mean one from here to here, or do you mean one from there to there, basically, and how are you setting it up? And we maintain those dotted arrows the whole time, right up to submit the answer, so that they're very clear on where they've actually made that particular bond. We also, essentially, if there is one over here, like a radical that they're going to do, we want them to blow it up and indicate it's the electron that's moving. So faculty were very clear on, like, go a step further in and have them show you what's actually happening, so that it's clearer to them. We are just in the process of doing this integration right now, so we do not know the usability results of this yet. This is the design we think is the right way to go. When we put 400,000 students against it, we'll know, right? And then we can come back and say to ChemAxon, I don't know, let's see how it goes. We're hopeful that this is going to help us. This is our basic system architecture. If anybody is interested, I have more details, and you can ask me after. But basically what we do is we have a front end of MarvinJS UI. We have essentially web service requests and evaluation requests. So the student draws a molecule, submits it. It goes essentially to the mastering server. It's an Apache web server. Mastering is written in Perl. And basically from there, we then have a JChem web service, and we also have our own. We basically broke out some of the JChem library and made our own OChem web service. So this OChem web service we have has the JChem library, which we now went up to JChem 6, and the ACE evaluator code from Bob Grossman. So essentially what happens is the drawing comes in, it goes into mastering. Mastering picks up the information from the author that says, these are the criteria for this question. These are the evaluators that must be true for this to be true. And we take that over essentially to our JChem web service and evaluator codes and make the evaluation. And basically what it does is it goes through each evaluator and checks the drawing against what is said, and then determines what the overall feedback is for it. If certain criteria are true, great. If other ones aren't, then feedback on those until we get to the point where they're all correct, and then it's correct, basically. It's extremely complicated in terms of that. And it is difficult, obviously, to grade organic chemistry drawings as if you were the instructor grading them by hand. That is the experience we are attempting to get. And it's a high bar. So Margaret's going to tell us some of the things that we would like to do going forward. And Effie's going to tell me some of these are not possible yet. But I'm OK with that. I'm going to wait.
All right, so looking at our next steps, we really would like to bring in MarvinJS and use it as our main drawing tool for all of chemistry. Right now, for general chemistry, as students are first learning how to draw structures, there are some information that we would like to make sure the students understand before we move on to organic, where we allow students to make some assumptions of what they do and don't know. So in general chemistry, we want to make sure the students are placing their lone pair electrons correctly. They know that the lone pairs, in this hydrogen peroxide, they know where the lone pair electrons go. Once they move on to organic, we accept that, yes, they know that the valence of carbon is 4. They know how many lone pair electrons you place around oxygen. So we start to fill that in for them. So MarvinJS is very powerful. And right now, when we grade organic structures, we grade mechanisms, we want students focusing on the reactions, the synthesis. We don't want them focusing on these little details. But for as earlier in chemistry, in our introductory and first semester courses, we want to make sure students know this information. So to bring MarvinJS into Lewis, we would need to make sure that students are adding the lone pairs, they're adding single electrons, we can grade that. Make sure that hydrogen atoms, students are adding those on their own, so you make sure we're grading valence so they know there's only 2 bonds to an oxygen atom. We want to make sure that students for our intro courses, they don't teach formal charges. So for our intro courses, it's important that we have brackets available so that students can indicate ionic species and the charge on that ionic species. For some of our general chemistry courses that we do teach formal charges, students can place those on the atoms, but for our even lower level classes, we need those brackets. And then moving on to organic synthesis as well, we have where we'd like to go farther into organic. So right now, MarvinJS is, we have a lot of tools for mechanisms, but to move on to synthesis problems, which is really key in second semester organic classes, we need to be able to grade, can students indicate their reaction conditions? So we would either need the students to be able to enter that text on that canvas so we can grade the reaction conditions, or have a drop-down menu, or have a list of reaction conditions they can pick from. So this is an area we're thinking of moving into so we can start grading these complex syntheses. Instead of having electron flow, we need to grade the product at each step. So we'd actually need a system that can start with the reagents, say after this first set of conditions, what is the product of this first step? And the system would actually need to be able to check and make sure that these products make sense, giving these reagents, these reaction conditions, that these are a set of products that make sense. And all the way through the synthesis, we start with our starting material, we end up with our final product that the whole thing makes sense. And finally, we're looking at synthesis maps. This is something that is a part of synthesis. So students, you can see in the previous slide, actually, one of the steps is to produce a carboxylic acid. So as students working through a synthesis reaction, they would try to build a synthesis map. How do I build my carboxylic acid? What are my precursors? And so this is something that we'd like to be able to do now, to be able to have students build these synthesis maps. We can place the text on the screen. That's one thing you would need, is to be able to, the author would be able to need to code that this text goes in these places, and then students would fill in the precursors to complete the map. So that would be, as you see with our hint structure, how we have students are being asked a specific set of questions. We have the hint as an instructor would go through to guide a student towards the right answer. So this is the type of thing we would work on if we're stepping students through. Well, how would you work on this synthesis? Well, synthesis map is a very basic tool in that regard, but we would need to be able to place text on the screen. The author would need to be able to code that in order to move forward with synthesis.
I think our main goal is we want to make this as easy for students as possible.
Right.
We want to encourage them to be able to put in organic chemistry answers, to be graded properly, and to have a really good experience so that it moves their learning forward. Organic is challenging. We want our students to succeed and retain them essentially in STEM education. And we don't want the tool to be any sort of impediment to them. Right. And so that we feel that MarvinJS is a step forward in terms of usability, in terms of user friendliness, and being something that will help our students improve, which is our main goal.
I have a question.
Okay.
Are any of the faculty members using this for assessment, not just tutoring, or are they actually using it as quizzes or tests? They are?
So there is testing and there is quizzing both. So people use mastering in a variety of ways. Some people use it for practice homework, some of it use it for graded homework, and some people do quizzes. There are people who do timed quizzes as well, and exams within the platform, and it depends on the instructor's preference on how they do that, but yes. So it is used for assessment.
Questions? I have one more. So for your backend, is Pearson hosting these servers, or you install them at the universities?
No,
Okay,
it's on Pearson's side, it's on our side, and then they access us, basically. And it is a fair amount, because if you think of the number of evaluations, how many transactions go through for each item, the number of students, basically we just have a lot of hardware against it at this point to sort of speed up those response times, because we don't want it to lag. Right, so that's definitely an issue, but it's hosted, it's on our side.
All right, and you sort of just sell a service package to the
Basically, we sell logins to students, essentially, and they log into our site and then access stuff from our side, basically. And instructors largely set up their own courses and decide what they want to pick out of the content to deliver. And we have a large item library that they can choose from.
Could an individual student seek this out just for like personal tutoring purposes?
So at the moment, they're driven by the instructor setting up a course. And so it's usually required for a specific course enrollment that instructor does that. There are some things that we have that are sort of student side study area type things that aren't the actual mastering thing itself, but most of it, it's instructor driven. The instructor decides to incorporate it into their teaching. I mean, with the flipped classroom starting to be really large in education, this idea of give content sooner, do some assessment before they come to class, and then actually do problem solving in class rather than talking at them, and then do some homework later to confirm that you've got where you wanted to get to. This is becoming more of a useful tool for faculty, basically.